All right, everyone, welcome. If you're watching this, you are about to start phase 1.4 where we are going to be creating a compass. Now, I really like this one, and I like these styles of challenges because what we're doing is we're getting to know our microbits. Microbits are incredible because of all the little things that they can do that are built into the actual microbit itself. So what we're going to do is we're going to take a close look here at our microbit. I'm going to put that in the center. Let's go ahead and give you that view. Beautiful. All right, so I'm showing this on a microbit V2, exactly the same detail. Other than the things being slightly different, it's kind of exactly the same thing. So what I want to do here is I want to show you what part, when we talk about doing a compass, what part of the microbit are we using. So here on the microbit, I'm going to use this to point, we've got our speaker here. So this is new on the microbit V2, you won't see it. All of them have this processor, and then just down below here on the V2 is this little chip down here in the bottom. So you can see here that this is two things. One, it's the accelerometer, and two, it's the compass. Now we'll be using the accelerometer in the next thing. That's the same thing that when you hold up your phone and it twists sideways, when you hold up your phone and it sort of knows which way to point based on which way you turn it. That's the accelerometer that's doing that, okay? But also built in here is the compass. Now think about a compass for a second. A compass uses the magnetic field generated by the Earth, and it's able to detect that, and we're able to use that to detect direction. Now this isn't a new thing. We can make a compass from water, cork, and a pin that's been rubbed with a magnet. But what we're going to do is we're going to create our own digital version of this, which is kind of exciting. So let's go into the wiki here, and here's sort of what you need to do. This wiki here is on a different platform. This is back on Notion. I just like the way Notion looks better, and I like that you can sort of go step by step. So let's take a look. What is the challenge that we are setting out to solve? So the challenge here, you are going to build a digital compass, and you're going to build just like a regular compass, a compass that always points north. So here are the outcomes. You can plan in response to a challenge. So I'm giving you a challenge to build a compass that always points north. We're going to make a plan based on this challenge. Then this one I'm excited about because you're actually going to do this. You've got some problems that you've got to solve as we do this. So I can solve problems in response to challenges. Number 3, I create a product, performance, or service in response to those challenges. So you're going to actually physically create a compass here that you could take out on a hike. Okay? And then finally, this one, as always, important to me, you are going to communicate your learning. So in Notion, in this one, we've got these little toggle drop-down menus. So my hope for you is that you would toggle the drop-down, okay, and then close it when you're done, and then move on to the next one. So here's our background. The idea is you're going on a backpacking trip. I'm just going to lower the volume down of here a little bit. Looks like I'm peaking a little bit. There we go. So you are going on a backpacking trip, and you're going to be creating a compass that you can use on an overnight trip, which means you'll need to use the battery to do this. It can't be connected to your computer. So here's what you'll need. You'll need a microbit, battery pack, USB cable, and then your computer to code it. Again, you can use the iOS app on your phone. We'll talk about that in a little bit. There'll be a separate video on how to sort of do the serial stuff with if you're on a mobile device. Okay? In the skills, you're going to learn how to use simple math to complete this challenge. There's a little bit of math in this one. Okay? We're going to learn how to use the microbits built-in compass, and we're going to learn how to use, last challenge we used an if-then statement. We're going to use an if and else statement. So we've got to sort of repeat that for how we're going to do this challenge. There's a bunch of ways we could do it, but we're going to do it this way. So what I need you to do now, every time you see a green check mark and the green bar, that means there's something for you to do. So please don't skip over any of these steps or you might miss what you need to do. So go ahead, pause this video, and make sure you've got all of these materials, the microbit, battery pack, USB cable, and your computer handy. All right, now if you're seeing a pattern here, step 1 is almost always identify the inputs and the outputs. Computer programming is not complex. We've got a set of inputs that we use, and we've got a set of outputs that we use. And so what we're going to do here is we are going to, hold on, I'm just going to turn off, looks like I've got a different audio thing on. Oh no, I'm fine. Beautiful. Just going to turn this down just a little bit more. There we go. Okay. That's our first step in all of these. So where are we getting our information from? What are we going to do with that information? When we can identify those first, it makes the process of actually coding this thing way simpler. So like we talked about, your microbit here has a built-in compass, all right? It's this little chip right here, just like we talked about. And so what we're going to do is we're going to get information from that chip, and we're going to use that information to display information here on our LEDs. So what I want you to do, on the attached worksheet that's part of the Google Classroom, that's part of, it'll be linked in this wiki as well. I want you to use this space here on the Google Classroom, or on the wiki here. Let's go fit. And I want to identify what your inputs and outputs are. So pause this video right now, take a stab at it. What do you think your inputs are? All right, so I'm going to give you the answer because I'm going to fill this out as I go here. So the inputs for what I'm putting in there, I'm looking for my compass information. Okay? And the outputs, I want to display the direction on my LEDs. Okay? So we're going to do a couple different ways that we could do that, and then you'll sort of pick one that works for you. Let's head back over to our wiki here. So that's this check mark. Use the space attached on the worksheet to identify your inputs and outputs for this project. Beautiful. Step number 2, we are going to write our rubber duck code. So we want to clarify exactly what we want this thing to do as it's happening. So use the space, not below, on your worksheet to write your rubber duck code. Plainly, as simply as possible, identify what you want your compass to do when it points in different directions. So let's go back here, rubber duck code. For this code, I want my compass, we'll call it a needle, to always point north. This means that the arrow, we'll use an arrow for this example here, will turn and stay pointing in the same direction as long as I am turning. Something like that. We'll refine this rubber duck code as we go. We just want to start this process of thinking like, as I am turning. Okay? So now we can head over here. Oops, wrong one. We have wrote our rubber duck code. So now we're getting ready to actually create something. So I'm going to stop this video here. We're going to go to the next video in the creation section, and we're going to look at actually building our code. So we'll see you in the next video.